So I would like you to write down the topic of today's lesson, which is exponential equations. Exponential equations. What is an exponential equation? Exponential equation has got a variable in the exponent. Okay.
Miss Natalia, will you post these videos?
Absolutely, yes. That's why I'm recording them. So exponential equations have got variable in the exponent, right? That's why they are called exponential equations. And if you remember in grade 11, you were able to estimate the value. Like if you had a variable in the exponent, you didn't know how to solve for it. You were just using trial and error in order to estimate the possible value of x. So this course, we're going to get the accurate answer. Two ways. There are two ways of doing this. So the first, that's why today we are taking the first part, which is solving exponential equations without logarithm, okay? But the second part, which will come after the laws of logarithm, will be about solving an exponential equation using logarithm, because some of the equations require logarithm, otherwise you cannot solve it. Okay, so today we're working only on the equations which can be solved without logarithm. And the basic concept which is used here in those types of exponential equations is if two exponential expressions have the same base, which means that left side and right side of the equation has got the same base, then they are equal only when their exponents are equal. For example, if a to the power of m is equal to a to the power of n, it means that m is equal to n. Otherwise, they will never be equal, okay? Of course, we remember that in exponential functions, the base has to be positive. The base also cannot be 1 because 1 raised to any power, nothing will change, okay? So that based on this concept, or this concept gives us the idea about how to approach those exponential equations. So all you need to do to solve an exponential equation is to write both sides of the equation with the same base whenever it's possible, and then afterwards you drop the base and set the exponents equal to each other. After that, you can solve for the unknown. And the logarithm is used when it's not possible to write left and right side with the same base. So this will be the next step. So we will start now solving some basic exponential equations, and then we will see how it might be applied in this idea, might be applied in more complex equations. Right, so have your handout ready. If not, then this is what we're going to work on. You can just follow my screen, and please make sure that you take notes. Okay? So I suggest that we first work on something as simple as question 6. Just let me zoom in, because I feel that it might be unclear. Okay, so I would like to start with the question 4 and 6. So let's work on 4 first. Question 4. Yeah. Okay, so we are working on this question. So we are to solve for the unknown. Unknown is a, in this case, right? So the first thing which we check is that left side, right side has got a single exponential expression. And then the second, so it's single, it's only one here and one here. By single expression, we mean that there is no addition, subtraction, and so on. So the second thing which we are going to check is whether the base is the same or not. So as you can see that the base is the same here. And once the base is the same, we know that if a to the power of m is equal to a to the power of n, that means that m is equal to n. We say drop the base and equate the exponents. So that means that what is going to be the next solution line? Anybody who knows, tell me.
Minus 2a. I mean, no, 2a equals minus.
Yeah, 2a equals negative a. Okay? And now this is the linear equation, which you know how to solve. What's the next solution line, please? Ideas?
Do you put the a on the other side, the negative a?
Absolutely. Yeah. So collect like, because we want to collect like terms, right? So 2a plus a is, what is on the right side if you move negative a to the other side?
3a. Oh, لا, 0, 0.
0. Now 2a plus a is like terms, right? Collect like terms. 3a is going to be equal to 0. So what's the value of a then?
0.
0. So 0 is the only solution for this equation. We can do the check to make sure that it's correct. I do recommend the check for these equations, okay? So let's sub in 0 instead of the unknown. So 3 to the power of 2 times 0 is 3 to the power of 0, right? 3 to the power of 0 is
1.
1. So this is the left side. Let's check now what happens on the right side. So 3 to the power of negative 0, right? So what shall I do with this negative exponent? How to evaluate it? It's a negative exponent, so apply the negative exponent rule. Any suggestions?
Miss, is it going to be 1 over 3 to the power of 0?
Absolutely right. Thank you. 1 over 3 to the power of 0. This is a negative exponent rule. So what's the next, Omar, next step then? If 1 over 3 to the power of 0 is equal to what?
1, so 1.
So it's equal to 1 over 1, which is 1. So the conclusion is that the left side is equal to the right side. That means that a equals 0 is the solution of this equation. All right? Now, let me do one more basic equation before we move on to something more exciting than that. Okay, so this one. No, I said 6, right? Okay, let's do 6. So, Laila, what's the next solution line? Laila, Ali. Miriam,
Yes.
next solution line.
2p equals negative 2p minus 1.
Okay, thank you. Kenzie, what shall I do next? Noor,
Yes?
what's the next
Oh, you
line?
move everything to the left
Right.
side. So
Not necessarily, not everything. It's a linear equation. In the linear equation, if you remember, we always move terms with the variable on one side and constants on the other side, right? So what's the next line? Tell me, Noor.
it's going to be 4p is equal to negative 1.
Absolutely. Okay. So what's the value of p then?
Negative 1 over 4.
Negative 1 over 4. Okay, let's do check. Right? It's really will help you to have control over your result in on the test, for example, using check. So the left side, 4 to the power of 2 times negative 1 over 4 is going to be negative 1 over 2, right? Okay, so Omar Hussein, oh no, you said this before. Who else? Anybody? How can I get rid of this negative exponent?
1 over 4 to the
Power 1 over 2.
Yeah, so 1 over 4 to the power of 1 over 2, which is the 1 over square root 4. So what is going to be the answer?
It's going to be half.
Half, right? Okay, so let's check the right side. Right side is this one. So 4 to the power of negative 2 times negative 1 over 4 is half, positive half, right? And then minus 1. Right, so it's gonna be 4 to the power of negative 1 over 2. So since it's negative 1 over 4 to the power of negative 1 over 2 is exactly the same thing as here, I don't need to complete the calculations, right? So I see that it's the same. So left side is equal to the right side. All right, so that's the idea, the basic idea. Now, sometimes the equation will not be, or like most of the time, the equation will not be as simple as that. Which means that the left side, the right side will need some kind of rearrangement in order to reach the situation where you have left side base the same as the right side base. For example, in question 5, as you can see, we have 4 on one side and 1 on the other side. So we need to do something in order to have the same base on both sides. Do you have any ideas about how to do it?
I
think we could think that what power, like 4 to the power of what gives 1, which is 0. So we're
Absolutely, yes.
Yeah.
So remember that 4 to a power with a variable can never be changed. You will not be able to change this, right? So, but 1 is a very nice number. It can become anything. So we know that anything to the power of 0 is going to be 1. So we need the base of 4. That's why we are going to use 4 to the power of 0 is equal to 1. So I'm going to replace this one with 4 to the power of 0. So I will have 4, 3x minus 2 is equal to 4 to the power of 0. So on the tasks, this step is a must, right? I have to see what happens. That you have to show me the step where you made the base same, and then you have the right to drop it in order to equate the exponents. So now we can drop the base, and the exponents are going to be 3x minus 2 is equal to 0, 3x is 2, and x is 2 over 3. Okay, right, any questions? So I suggest that we do another question together, and then I'll give you 10 to 15 minutes of practice on individual basis for the similar questions. And then afterwards, we will move to the next step. So let's check this question. Okay? So it's less straightforward. So we have 3 to the power of 1 minus 2x, and we have 243. Any ideas what to do? Like are you already doing something, or you are lost and you don't know what to do? No? Okay. Miriam, do you have any ideas?
No, I'm just trying first. I was
trying.
square rooting
Tell us, what are you trying?
I tried square rooting 243, but I didn't get like a number.
Yeah, why square rooting? I don't know. So let's identify what is my guideline here, right? What should guide me? What am I trying to achieve, Miriam?
We're trying to look for the exponent of 3.
Absolutely. So this is your guideline. So I want to have 3 to the power of something instead of 243. It means that, so you just need, exactly. You just strike different powers of 3.
Yes,
that's it,
it's
right?
5.
So it's 5. Jana, are you able to participate, or the mic is broken? More.
Yes, miss.
Okay, so what's the next solution line?
We remove the 3's.
No, we don't move it anywhere. Like, you mean we drop it, yes? Yeah,
Right.
just tell me what to write.
1 minus 2x. equals 5.
Right.
And then you move
Next
the 1 to the other side. It's going to be 2x equals 5. plus
y2, you
negative.
moved 1, negative 2x.
It's
Is
going to be
equal
5
to...
subtract 1. 4.
So what's the value of x?
It's going to be negative 2.
Negative 2, okay. All right, so let's stop at this point and practice the similar equations. I'll tell you what to do now.